Namaskar. Today I am going to give a talk on ocean currents. The topic of the ocean currents have the following contents. One is introduction, followed by types of ocean currents, upwelling and downwelling of ocean currents, ocean surface circulation, then significance of ocean currents, and finally the conclusions. Let us start from first module, that is introduction. The earth is a sphere spinning on its own axis and it is tilted. Due to this, the solar energy warming the earth is not uniform. The equatorial regions receive more solar energy than all other regions on the planet. The planet earth consists of more than 70% of water. Ocean currents are masses of ocean water that flows from one place to another. The amount of water can be large or small. Currents can be at the surface or deep below, and the phenomena that create them can be simple or quite complex. Simply put, currents are water masses in motion. Huge current systems dominate the surfaces of the major oceans. These currents transfer heat from warmer to cooler areas on earth. Just as the major wind belts of the world do, wind belts transfer about 2/3 of the total amount of heat from the tropics to the poles. Oceans surface currents transfer the other third. Ultimately, energy from the sun drives surface currents and they closely follow the pattern of the world's major wind belts. As a result, the movement of currents has aided the travel of prehistoric people across the ocean basins. Ocean currents also influence the abundance of life in surface waters by affecting the growth of microscopic algae, which are the basis of most oceanic food webs. More locally, the surface currents affect the climates of coastal continental regions. Cold currents flowing towards the equator on the western sides of the continents produce arid conditions. Conversely, the warm currents flowing poleward on the eastern sides of the continents produce warm, humid conditions. Ocean currents, for example, contribute to the mild climate of northern Europe and Iceland, whereas the conditions at similar latitudes along the Atlantic coast of North America, that is such as Labrador, are much colder, initiating deep currents that help regulate the planet's climate. These waters are most essential media through which heat is circulated around the globe. Circulation of heat in the oceans takes place in three ways. One, waves. These are caused by wind which form an oscillating movement of the ocean's water, followed by tides. These are caused due to the gravitational pull of the sun and moon on the earth, and currents caused by surface winds and differences caused by the temperature and salinity of seawater. Currents are the horizontal and vertical circulation of ocean water from the tropics, that is hot regions, to the poles, that is the cold regions. Currents can be very useful for the ocean life as well as for human beings. Currents vary in size, strength and importance. However, they are broadly classified into two types based on how they originate. There are two types of ocean currents. One is surface current, another is deep water currents. Surface currents are caused by prevailing winds up to a depth of 400 meters. These currents consist of 10% of the ocean water. The deep water currents are caused by density differences of the seawater due to temperature and salinity. These currents are beyond the 400 meters depth and make up 90% of the ocean water. So, let us discuss in detail. Surface currents. Surface currents are mainly wind driven. The factors responsible for the cause of these winds are Coriolis effect, and another is wind. Then what do you mean by Coriolis effect? The earth rotates anti-clockwise on its axis. This rotation of the earth gives rise to anti-clockwise force known as Coriolis force. The effect experienced by this force is known as Coriolis effect. The Coriolis force tends to deflect objects to the right in the northern hemisphere and to the left in the southern hemisphere. Coriolis effect is maximum at the poles and nil at the equator due to a rotational speed differences of the earth. That means, each latitude spins at different speeds. When wind blows over the ocean surface, due to friction it drags the water. The movement of water is to the right of the wind direction. Due to Coriolis force, the direction of the water movement is obliquely right, that means 45 degree to the wind direction. One rule of thumb to be remembered is that the current speed is 2% that of the wind speed. For example, if wind blows at 100 centimeters per second over the ocean surface, the current speed will be 2 centimeters per second or 2% of the wind speed. As the top layer of the water moves, it drags the layer of water underneath it. The force which propagates this movement is diminished with each successive layer. This spiral effect is known as the Ekman effect. So, then what do you mean by Ekman spiral? In 1902, V.W. Ekman, a Swedish oceanographer, provided a theoretical model to explain the origin of currents resulting from a steady wind blowing over the ocean. The movement of direction of the water is 45 degree to the right of the wind direction in the northern hemisphere and 45 degree to the left in the southern hemisphere. As the depth increases, the water tends to move to the right until the water movement is opposite to the wind direction at a depth known as Ekman depth. The entire spiral of water is known as the Ekman spiral. The net water transported during this process is known as Ekman transport. Then gyres. These are the surface currents flowing in a closed circulatory system. A gyre consists of 4 currents: a cold current on the eastern boundary, a warm current on the western boundary, and 2 parallel currents in the north and south of the gyre. The direction of gyre is clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. The gyres are mainly centered between 20 to 30 degree north and south latitude. This region is also known as subtropical high pressure zone. Gyres are found in all the world's ocean. The main ocean gyres are as follows: North Atlantic gyre, South Atlantic gyre, Indian Ocean gyre, North Pacific gyre, South Pacific gyre, etc. The center of these gyres is stable with no circulation of water. Only on the circumference of these gyres currents operate. Also, the marine life in the center of these gyres is 3 or 4 times less than elsewhere in the oceans. This is due to lack of nutrients, as there is no circulation of water. Deep water currents. These currents are caused mainly due to density differences of sea water. Because of temperature and salinity, the water circulation is mainly vertical than horizontal. The depth of these water currents may extend to 1500 meters. For example, the Gulf Stream current. These deep ocean currents are responsible for carrying oxygen to the depth of the ocean, enabling marine life to exist at such depth. The speed of these currents is much less compared to that of surface currents. However, the speed of these currents may even reach 40 centimeters per second. Now, the third module is upwelling and downwelling. In deep oceans, the water circulation is both horizontal and vertical. These deep ocean currents bring nutrients to the surface, and this movement of nutrients is a vertical movement. The two main vertical movements are, one is upwelling and another is downwelling. Upwelling: the surface water is warm and depleted of all nutrients. When winds blow over the surface of the ocean water is pushed away. In order to compensate for the pushed away water, cold nutrients and rich water rises to the top, and this is known as upwelling. The 5 most important upwelling regions of the earth accounts only 1% of the ocean's area, but they are responsible for almost 50% of the world's fisheries and fishing industries. Upwelling regions are high productivity regions. Then coming to downwelling, water is heated at the equator and is circulated to the poles by warm currents such as Norwegian currents. When water reaches the poles, it becomes more saline, as fresh water tends to become ice more readily than saline water. The excluded salt mixes with the already saline tropical water and sinks due to increase in density. This water is void of nutrients and hence not much of productivity in these regions. Then thermohaline circulations. This is another type of circulations which we find in oceans. As the name indicates, it is a vertical circulation of ocean water. This circulation is caused by density differences of sea water due to variance in temperature and salinity of the sea. Sea water with depth. This circulation is also known as global conveyor belt because of the thorough mixing of the surface and deep waters. This circulation involves the interaction of surface and deep ocean currents. These interaction zones are the upwelling and downwelling regions of the earth. Thus, this global conveyor belt is very important to marine life due to the transportation of nutrients in the vertical transportation of warm, less saline water and cold and saline rich water. Ocean surface circulation, it is a part of ocean currents. The pattern of ocean currents, the pattern of surface currents varies from ocean to ocean depending upon the geometry of the ocean basin, the pattern of major wind belts, seasonal factors and other periodic changes. Let us take up the Antarctic circulations. Antarctic circulation is dominated by the movement of water masses in the southern Atlantic, Indian and Pacific oceans, south of about 50 degrees south latitude. Circumpolar current is the only current that completely circumscribes Earth and is allowed to do so because of the lack of land at high southern latitudes. It meets its greatest restriction as it passes through the Drake Passage, named for the famed English sea captain and ocean explorer Sir Francis Drake, 1540 to 1596, between the Antarctic Peninsula and the southern islands of South America, which is about 1000 kilometers, it is approximately 600 miles wide. Although the current is not speedy, its maximum surface velocity is about 2.75 kilometers, that is 1.65 miles per hour. It transports more water and an average of about 130 million cubic meters per seconds than any other surface currents. The Coriolis effect deflects moving masses to the left in the southern hemisphere. So, the east wind drift is deflected towards the continent and the Antarctic circumpolar current is deflected away from it. This creates a divergence of currents along a boundary called the Antarctic divergence. The Antarctic divergence has abundant marine life in the southern hemisphere. Summer, because of the mixing of these two currents, which supplies nutrient rich water to the surface through upwelling. Let us coming to the another important ocean, that is Atlantic Ocean circulations. In case of Atlantic Ocean surface, the surface circulation consists of two large subtropical gyres, the North Atlantic, that is Columbus gyre, and the South Atlantic, that is Navigator gyre. The North Atlantic subtropical gyre, that is Columbus gyre, rotates clockwise, and the South Atlantic subtropical gyre, that is Navigator gyre, rotates counterclockwise due to the combined effects of the trade winds. The prevailing westerlies and the Coriolis effect, each gyre consists of a poleward moving warm current and an equatorward moving, that is cold return current. The two gyres are partially offset by the shapes of the surrounding continents, and the Atlantic equatorial counter current moves in between them. Then Indian Ocean circulations, because India is also considered to be one of the important oceans we come across. Because of the shape and position of the India, the Indian Ocean exists mostly in the southern hemisphere. From November to March, equatorial circulation in the Indian Ocean is similar to that in the Atlantic Ocean, with the two westward flowing equatorial currents separated by an eastward flowing. Equatorial counter current as compared to circulation in the Atlantic. However, the equatorial counter current in the Indian Ocean lies in a more southerly position, because most of the Indian Oceans lies in the southern hemisphere. The shape of the Indian Ocean basin and its proximity to the high mountains of Asia cause it to experience strong seasonal changes. Then let us coming to the Pacific Ocean circulation. Two large subtropical gyres dominate the circulation pattern in the Pacific Ocean, resulting in surface water movement and the climatic effects similar to those found in the Atlantic. However, the equatorial contour current is much better developed in the Pacific Ocean than in the Atlantic, largely because the Pacific Ocean basin is larger and more unobstructed than the Atlantic Ocean. The North Pacific subtropical gyre, that is Turtle gyre, includes the north equatorial current, which flows westward into the western intensified, that is Kuroshio current near Asia. The warm waters of the Kuroshio current make Japan's climate warmer than would be expected for its latitude. This current flows into the North Pacific current, which connects to the cool water California current. The California current flows south along the coast of California to complete the loop. Some North Pacific Current water also flows to the north and merges into the Alaskan Current in the Gulf of Alaska. South Pacific Subtropical Current that includes the South Equatorial Current, which flows westward into the western intensified East Australian Current. From there it joins the Antarctic Circumpolar Current, west wind drift, and completes the gyre as the Peru Current, also called the Humboldt Current. Ocean currents or the ocean is transportation system useful for both marine lives as well as to human beings. The ocean currents significance ranges from water circulation to helping meteorologists predict and forecast weather more accurately. Ocean currents are very essential in transporting 20% of the latitudinal heat. Hence, this heat transportation influence the local weather conditions. For example, the Norway current is warm current carrying warm water from the tropics to the poles, and this results in a warm west coast in Europe. The result is vice versa. When a cold current moves from poles to the tropics, transportation of heat also leads to transportation of nutrients. Without ocean circulation, the ocean would be lifeless, but due to circulation, oxygen is moved from surface to deeper part of and colder, nutrients rich water is upwelled. The upwelling sites encourage seaweeds which are consumed by phytoplanktons. These in turn are eaten by a small fish, molluscs, etc., which become the food for animals higher in the food chain. This increased productivity due to ocean currents give rise to economy through the fishing industry and other industries. Fishing is no more a game of luck, but due to advanced technology, currents is traced, studied, and the fisherman can pinpoint the right location for fishing. Not all fish live in one type of water. The marlin prefers a warmer waters, whereas the anchovies prefer a colder water. By locating these regions by complex equipment, fisheries are blooming. Ocean currents are like oceans, rivers, hence they are very useful for the shipping industry. Using currents, the fuel and travel time is reduced, hence greater profit for the shipping industry, and also goods are delivered much quicker. Ocean currents are also very significant in the study of pollution. The myth of everything used dump in the sea sinks to the bottom is vanquished. Certain materials like plastics, oil spills, and nuclear waste do not sink, hence they become very harmful wherever the current carries them. By locating the currents carrying these wastes, cleanup and restoration can be made possible more quickly. Also, the behavior of ocean current movement can be studied by the movement of these wastes. Ocean currents are also helpful to geographers, meteorologists in better understanding of ocean and atmosphere interaction. These interactions help in understanding of the formation of cyclones, which in turn help in better weather forecasting. Ocean currents are the continuous circulation of ocean water. Currents caused by prevailing winds are known as surface currents. The movement of these currents are predominantly horizontal. Currents caused by thermohaline circulation are called deep ocean currents. Currents are responsible for water circulation such as warm tropical water to poles and vice versa. The vertical movement of water involves the upwelling of nutrient rich water to the surface. Downwelling is the sinking of nutrient depleted water. The significance of ocean current is very essential for movement of nutrients, organisms, and helping meteorologists for better weather forecasting. This helps in rich abundant productivity of marine life, which in turn drives the economy of many countries around the globe.